Okay, everybody. Today we will start the digestive system. First, we'll see the parts or organs of this system. Then we'll see the processes take place in the digestive system. Then we'll talk about the peritoneum. Peritoneum is a serous membrane, double-layered serous membrane that covers the abdominopelvic organs. Okay, so that is the double-layered covering. Like you know, pericardium around the heart, right? Pleura, double-layered around the lung. Similarly, around your abdominal organs, you have peritoneum. Then we'll talk about the first organ of the digestive system, which is the mouth or oral cavity. We'll see the structure of the mouth, and then we'll talk about the structure of the gastrointestinal tract or GI tract. How many layers you have in the wall of GI tract, and what are those layers? Then we'll talk about the secretion. You know that inside the stomach, intestine, right, secretion occurs. Mouth or oral cavity secretion occurs. So how the secretion in your GI tract is regulated or controlled? There are two reflexes, short and long nerve reflexes. They regulate the secretion in your GI tract. Then we'll talk about the nerve plexuses in the wall of GI tract. Movements, a very important topic, movement of GI tract. If the GI tract doesn't move, the food will not move inside it. Make sense? And if food doesn't move, then it will be a big problem. We'll talk about the mouth first, the first organ of GI tract, then we'll talk about other structures or other parts like esophagus, stomach, small intestine, large intestine. We'll talk about those parts or organs, okay, of GI tract. First, the organs of your digestive system. Digestive system is divided into two parts: gastrointestinal tract or GI tract and accessory organs. Okay. GI tract is a long tube from the mouth to the anus. So it is a long tube from the mouth to the anus. Okay. Now, this tube has different parts, but it is a continuous tube, right? So, it is a continuous long tube, that is GI tract, but this tube or GI tract has different parts. So, first organ or part of it is the oral cavity or mouth, then you have the pharynx, right? Then esophagus, then stomach, small intestine, large intestine, okay? Continuous long tube starts at the oral cavity or mouth. Now you see this tube in some places get narrow, some places get what? Wider. Make sense? For example, your esophagus is a narrow tube, right? Narrow tube. Then the esophagus gets what? Very wide to form the stomach. After esophagus, that narrow tube is what? Stomach, right? Which is wide. And then it gets again narrow to form what? Small intestine, long narrow tube, right? Then gets wider to form large intestine. So you see, it is a continuous tube from the mouth to the anus, but at some locations the tube is what? Narrow, some locations wider. Make sense? So those are the parts: oral cavity or mouth, pharynx, esophagus, stomach, small intestine, large intestine. Those are the parts of your GI tract. Now, accessory organs are outside of that tube, but helping the functions of the digestive system: liver, pancreas, tongue, teeth, gallbladder. So those are the accessory structures or organs of your GI tract. Okay. Processes take place in GI tract. 6 processes take place in the GI tract or digestive system: ingestion, propulsion, mechanical digestion, chemical digestion, absorption, and defecation. Ingestion, very simple. You see, putting the food in your mouth. That's the first process, right? You put the food where? In mouth. So that is ingestion. Then you tell me, after you put the food in your mouth, next what you do? Chew the food, right? Chew the food. By moving what? Jaw, mandible, right? And that is mechanical because we break by pressure, right? Cutting, chopping, crashing by teeth. Make sense? So that is mechanical or chemical? Mechanical. By pressure, right? We cut it, chop it, crush it, right? In the mouth. So mechanical digestion. Digestion is what? Very simple. Breakdown of food. Breakdown of food is digestion. Is it clear? So that is mechanical digestion. Now also inside the mouth, what happens? Secretion of saliva. You know that, right? So saliva has the chemicals that also break the food. So that is chemical or mechanical? Chemical. So both mechanical and chemical digestion or breakdown of food occur inside the mouth. Is it clear? So saliva, chemical, by pressure, by the teeth, cutting, chopping, crushing, mechanical. Okay? Then the digestion continues. After food goes to the stomach, secretion of acid and other digestive secretion occurs, right? So further breakdown occurs there. So breakdown continues or digestion continues. First part happens in the mouth, but also in the stomach and the small intestine. Absorption. After digestion, the large food becomes fine molecules. So digestion converts the food into fine molecules. That is digestion, breakdown. Okay? Digestion. The food is converted into fine molecules. And these fine food molecules are called what? Nutrients. Make sense? So nutrients are fine food molecules. And after that, what happens? Absorption. That means these fine food molecules or nutrients are taken into the blood by absorption. So by digestion, what happens? Food becomes fine food molecules or nutrients. Is it clear? And then the fine food molecules or nutrients are taken where? Into the blood. That is called absorption. Is it clear? So absorption mostly occurs in the intestine, right? Digestion in the mouth, stomach. And then fine molecules are taken into the blood in the intestinal wall. And then the foodstuffs, those are not taken into the blood, remains in the GI tract, right? And eventually gets out from the body as feces, and that is called defecation. Make sense? So those unnecessary foodstuffs remain in your intestine, will get out from the body as feces, and that is called what? Defecation. Okay. So those are the processes take place in your GI tract. This picture is showing those processes. Okay. Peritoneum and peritoneal cavity. Peritoneum is a double layered serous membrane. Serous membrane, double layered. And let me try to draw here. This is your thoracic cavity, diaphragm, then the abdominal cavity. Okay. So this is the abdominal cavity. This is thoracic cavity. And you have liver, intestine, small intestine, large intestine, those structures in the abdominal cavity. What happens? This is the abdominal wall. Abdominal wall. So, a layer of serous membrane is attached to the inner surface of the abdominal wall, like this. You see here, like this, attached to the inner side of the abdominal wall. And then it moves inwards like this and covers the abdominal organs. Like if this is liver, it is covering, going inwards and covering the liver, covering the small intestine like this. If your stomach is here, this is stomach, okay? Going from here to around the stomach, covering those organs. So you see here, this red line is showing the peritoneum, and it has two layers. One layer is attached to the wall of the abdomen, that is called the parietal. That is the outer one, right? So parietal, peritoneum, and the one that is going inwards and covering the internal organs like your liver, stomach, intestine, that layer around the organs, that is called the visceral peritoneum. Okay, so parietal is attached to the wall, visceral is attached to the organs. Okay, so double layer serous membrane. Now you see, if I make a cross section like this, if I cut like this, okay, and see the abdominal cavity, only this part. This is the cross section here. So I'm just making a cross section. So this is the abdominal cavity, abdominal wall, okay, and this is the layer attached to the abdominal wall. So this peritoneum is what? Parietal or visceral? Parietal. Make sense? Attached to the wall. And from there, what happens? Goes inwards like this and covers the internal organs. For example, this is your liver, this is your stomach. So covering the organs like this, then going like this to another organ, covering it like this. Okay. So this is the parietal peritoneum. This is the visceral peritoneum. Make sense? Okay. Now you see there is a big cavity between parietal and visceral, right? Big space here, and that is called the peritoneal cavity. Peritoneal cavity. Make sense? A space. And this cavity, you must remember, around your heart you have pericardium, right? It also has two layers. Outer layer is what? Parietal. Inner is visceral. Pleura around your lung has two layers, right? Double layer. Outer parietal, inner fluid. And in between you have cavity. Similarly, in between those two layers you have what? Cavity. In this case the cavity is huge, big cavity, peritoneal cavity. And that cavity contains the fluid that is called the peritoneal fluid. Peritoneal fluid. This fluid is very important because you have a number of organs inside your abdomen, right? You know, you have liver, gallbladder, right? Pancreas, spleen, stomach, intestine, all those organs are here, right? Inside the abdominal cavity. And that fluid in the peritoneal cavity prevent the friction between them because so many organs are there, right? So if there was no fluid, then they would have rubbed each other. Make sense? And that will cause what? Pain, inflammation. If two organs rub each other all the time, then what will happen? Inflammation. You know that, right? If you keep rubbing, inflammation will occur. Pain will occur, right? Severe. So that is being prevented by that fluid, peritoneal fluid, right? Now sometimes peritoneal fluid is a problem, can cause problem if, you know, just think that you got stomach ulcer in the stomach, okay? Perforation. Gradually the wall is getting, you know, a hole is being created in the wall, and if that happens, then what will happen? Food stuffs will leak out. Make sense? Stuff from the stomach will get out and will mix in the peritoneal fluid, right? And peritoneal fluid is everywhere. So it will quickly spread around all the organs. And that can cause severe consequences. Okay? That's, it's like, you know, you are spreading poison in your abdominal cavity. All organs could be affected, and anaphylactic shock. Persons, you know, can go to shock, severe pain, because inside the stomach you have acid, you know, the fluid is acidic, right? So if that comes out, or, you know, toxic food stuffs come out, that can cause severe problem. So quickly can spread and go to harm the other organs. Otherwise, this fluid is very helpful prevent the friction between the organs. Now, another thing you need to know, the part, you see, the parietal layers are going inwards, and this part that is connecting the parietal and visceral. This is called mesentery. This is mesentery. Okay, the double layered folds are going from the wall, abdominal wall, to the organ, or from organ to organ. Those are called mesentery. Here you see from the wall to the organ, or organ to the organ. Double layered structure called mesentery. Now, mesentery has some importance. Number one, you can just think here. Look at this picture. My beautiful picture. Okay. Look at this. So, from the wall, this mesentery is going to the internal organ, right? So, there, the mesentery are like ropes tying the organs to the wall, body wall. Make sense? Tying the internal body organs to the wall of the body, right? And keeping them in right locations. As I have mentioned, you have several organs inside the abdominal cavity, right? It's a big cavity. If you don't tie the organs, then they will all go to the bottom, right? And will stuck. You don't want them. You don't want them to. You want them to stay in their locations, right? So they are being tied to the body wall. So that is number one. Mesentery keep the organs in right locations in the abdominal cavity. Number two, from the body wall, you see here, blood vessels and nerves go to the internal organs through the mesentery, because it is a double layer, and in between two layers you have a space. So the blood vessels, like this, go to the organs. Nerves go to the organs. Lymphatic vessels. So those important structures pass through the mesentery. So that is number two. Number three, fat, a lot of fat accumulates around the mesentery. So storing fat or adipose tissue. So those are important functions of mesentery. Now, most of the organs are in the peritoneal cavity. So most of the abdominal organs are in the peritoneal cavity, but there are a couple of organs, those are outside of the peritoneal cavity. If this is the back of the body, this is the front, your kidneys are located here. You see, two kidneys located in the back here, and they are not in the peritoneal cavity. They are outside of the, or behind the peritoneal cavity, and these are called retroperitoneal. Retroperitoneal organs. Those are not in the peritoneal cavity, but outside of the peritoneal cavity. Example, your kidneys. But most of the organs are intraperitoneal. Intraperitoneal, these are intra means inside, peritoneal organs. Most of the organs are intraperitoneal, inside the peritoneal cavity. Few organs are outside, those are called retroperitoneal organs. Okay. Okay, now we'll see the structure of the mouth. The first or uppermost organ of your GI tract. Mouth is also called buccal cavity or oral cavity. Boundary. You know, all of you know, the lips, right? Upper and lower lips are the anterior boundary of the oral cavity or mouth. Palate. So here you see the lips, anterior boundary. This is the oral cavity or mouth. So anteriorly lips. The roof is formed by the palate. Hard palate and soft palate. Floor is formed by the tongue. This is the tongue. So floor of the mouth is the tongue. Okay. So, and the lateral walls, both sides, you see here, lateral walls are by the cheek or the cheek muscles. So that's the boundary of the oral cavity. Lips anteriorly, roof palate, floor tongue, lateral wall by the cheek. If you see inside the mouth, a number of structures you will see. You have teeth, you have gum, you have palate, you have uvula, which is the end of the soft palate. Under the tongue, you have frenulum. In between the gum and the lip, you have frenulum. You see here. This is the gum, this is the lip, and this tissue, small tissue structure is called the frenulum. Under the tongue, you also have frenulum. Now, this is simple. This frenulum is called labial frenulum because lip, labial, labi, okay, lip. This frenulum is attached to the tongue, that's why it is called lingual frenulum. Make sense? Lingual means tongue. So, frenulum, this is inferior labial frenulum because lower lip, that is superior labial frenulum attached to the upper lip and gum. So, those are frenulum. Openings of the salivary glands. You know that saliva is secreted in the oral cavity, right, or mouth. So from the glands, salivary glands, the ducts bring the saliva and gives the release the saliva into the oral cavity or mouth, right? So there must be openings for those ducts, right, or tubes. So under the tongue, you have openings of sublingual ducts, come from sublingual salivary glands. So those are some structures you can see in the mouth. Palate. Palate has two parts. Hard part or bony part is the hard palate. Soft part, which is the skeletal muscle structure, is called the soft palate. Now, hard palate is the bony part formed by two bones. So if this is the palate, this is the hard part, this is the front, this is the back. Anterior 2/3 of bony part is formed by maxilla. Anterior 2/3. Posterior 1/3 by palatine. Palatine bone, which forms posterior 1/3. So this is the hard palate, this part. Soft palate is formed by what kind of muscle? Skeletal muscle. So this is skeletal muscle. Forms the soft palate. Soft palate. Okay. Skeletal muscle is covered by a thick layer of mucosa. So this is a thick mucosal layer around the skeletal muscle. Okay. So inside is a skeletal muscle and outer layer is a thick layer of mucosa. The free end of soft palate is called uvula. Okay. That can move up and down. So that is the palate. Tongue, another important organ inside the mouth. Tongue is a very interesting organ of your body. Why? Because it has interesting functions. Okay? The tongue has different types of functions. By moving your tongue, you do what? You talk? Yeah. Number one. Also, you mix the food with saliva, right? By the movement of the tongue. You make food bolus, right? By mixing the food and saliva. Make sense? You make food bolus. After you make food bolus, your tongue does what? Pushes the food to the pharynx. Make sense? So you use the tongue to start swallowing, deglutition. Make sense? So those are important functions. Another very important but different function is what? Tasting the food. Taste of food, right? Your tongue has taste receptors and they help to taste the food. So you see, your tongue has different types of functions, right? And they're different from each other. And tongue is the only organ which has the highest degree of movement, flexibility. You can move your tongue in many different directions. You can protrude the tongue, right, outwards, retract the tongue, right? You can make all different types of movement of the tongue because you have the muscles. Now, two types of muscles are in the tongue. This is the tongue, okay? Inside the tongue, those muscles are called intrinsic muscles. Inside the tongue, remember. Intrinsic tongue muscles, because they are inside. Intrinsic muscles. And from outside, like from the bones of your face, some muscles come from around, from outside, like this. And these are called what? Extrinsic. Makes sense, right? Coming from outside, bones. These are extrinsic tongue muscles. Make sense? So we can say tongue's own muscles are intrinsic muscles, right? That form the tongue. And the muscles coming from the bones around, those are extrinsic muscles. Now, you see, this is the tongue, okay? So, extrinsic muscles do what? Move the tongue in different directions, right? The muscle coming from this way will move this way, right? Coming from above will move up. Make sense? So, extrinsic muscles are helping to move the tongue in different directions. Is it clear? Now, intrinsic muscles do what? Think that inside the tongue, you have intrinsic muscles. And if those intrinsic muscles get shortening of intrinsic muscles will do what? Make the tongue shorter. Make sense? Will retract the tongue. Make the tongue shorter. If those muscles relax, the tongue will get long. Make sense? So the shape of the tongue is changed by what? Intrinsic or extrinsic? Intrinsic. Is it clear? Yes, sir. Shape is changed by intrinsic. But movement in different directions by extremity. Is it clear? So, two types of muscles help in the movement of the tongue. Okay. On the surface of your tongue, you have seen tiny structures, dots like structures, right? So, those are called papilla. You can see on the surface of the tongue. There are 4 types of papilla: palate, filiform, fungiform, circumvallate. So those are 4 different types of tiny structures called papilla on the surface of the tongue. Why papilla are important? Because inside the papilla you have the taste receptors. Inside the papilla you have what? That helps to taste the food, which is very important, right? Part in your life. If you don't taste the food, everything is boring. Okay, so taste receptors are present inside the fungiform, circumvallate and filiform papilla, but taste receptors are not present inside the filiform. So, taste receptors are present in 3 types of papilla: fungiform, circumvallate, foliate. Filiform doesn't have taste receptors. Now, if you see the surface of the tongue, you see tiny dots in the anterior part of the tongue. These are fungiform papilla. In the back part of the tongue, you have larger papilla. They form inverted V shape, and they are not many. They are like 8 to 16 in number, and these large papilla that are present in the back part of the tongue and form inverted V, those are called circumvallate. Circumvallate papilla. At the both sides of the tongue, only in the back part, posterior part, you have foliate. Foliate papilla. They are like folds. So these are foliate at both sides of the tongue. So fungiform, circumvallate and foliate. The taste receptors, as I mentioned, are located inside the papilla. So, if I go from large to small, first is the tongue. On the surface of the tongue, you have papilla that you can see. And now, if I open a papilla, cut the papilla and see inside it, I will see taste buds. And now if I open the taste bud is like this, oranges. Okay? This is a taste bud, and inside the taste bud you have the taste receptors. Interestingly, inside the taste bud, which is like an orange, you have the slices. Inside the orange, you know that those are the taste receptor cells. and different type of taste receptor cells are inside the bud. So these are the taste receptor cells. Okay, nucleus inside. Right. Why did I draw using different colors? Because different taste receptor cells have different types of receptors. Some are for sweet, some are for sour, some are for salt, right? So you have, different tastes and given by the receptors present in the receptor cells. For example, this is for sweet, this is for sour, this is for salt, this is for umami. Okay? Now, these are the taste receptor cells, remember, not the receptors. Now, on the upper end of these receptor cells, you have hair-like structures, like this. And the receptors are fine, small molecules, protein molecules. Receptors are attached to the hair. So these are the receptors. So remember, receptor cell and receptor are two different things. These are the receptors. These are the receptors attached to the hair of the receptor cells. So now we can say taste bud is this whole thing like an orange, right? Of course, not that big, very tiny. You have to see under, do under the microscope. If you can open the taste bud, like you open the skin of the orange, right? Peel it, you see slices inside, right? Slices are the receptor cells. Receptor cells. And then you have the receptors attached to the hair of the receptor cells. So, receptors, okay, on the hair. So this is from large to small. Tongue, papilla. Inside the papilla, you have taste buds. Inside the taste bud, you have the taste receptor cells. And on the hair of the receptor cells, you have the receptors. Okay. This is the top part of the taste bud. Here you have an opening that is called pore. Opening. This is the taste bud, and at the top of the taste bud you have an opening that is called pore. And now you see what happens. This is the surface of the tongue. When you put the food molecules, food stuff on the tongue, if the food is dry, very dry food, okay, they cannot enter into the taste bud because dry food molecules cannot move, right? When salivary secretion occurs, that's why salivary secretion is very important. When salivary secretion occurs, dry food gets mixed with water, right? Saliva. So now the water mixed fluid can easily pour into the taste bud, easily enter into the taste bud. Make sense? Mix with saliva, it can enter. And the food molecules bind with the receptors. And when that receptor and food molecule binding occurs, then signal goes through the cell to the brain. Okay? And you taste the food. That's why this binding is very important. Now you all know, if your tongue is very dry, your mouth is very dry, right? If you put the dry food in the mouth, you don't taste it, right? So it takes little time after salivary secretion, right, occurs, then you start to taste the food. You know that, all of you know that, right? So when the saliva gets mixed with the food, then the food molecules can go in and bind with the receptors. Okay, that activates the cells. Cells will send signal to the brain, your brain will give you the perception of taste, right? It is sweet or sour, depending on what type of taste receptors are activated by that food molecule. So that's the salivary glands. Salivary glands, there are three sets: parotid, submandibular, sublingual. Parotid is the largest here, the front and slightly below the ear. So you have the parotid salivary glands. Submandibular is under the mandible, right? Its name is telling you, under the mandible. Sublingual, under the what? Tongue. Okay. So those are the salivary glands. The saliva is highly watery secretion.